Hi everyone, this is our next set of slides. Now, as you know, normally I teach muscles, bones, then joints, then muscles. Because of the nature of the forearm and the muscles that relate to the hand, I have found over time that it's far better to talk about the forearm bones, the elbow joint, and the two radial ulnar joints, and then go directly into the bones of the wrist and hand, and then the joints of the wrist and the hand, and then go into the muscles. I just think it's a lot less complicated for you. So our next set of slides here then will be the bones of the wrist and the hand, and you can see here that we've got some. If we just think of what a hand actually does anatomically, you don't really take the time to consider it when you do all the things that a hand does. Grabbing, grasping, twisting, turning, writing, scratching, pushing, pulling, pushing buttons, and so forth. All those actions take particular configurations of joints and ligaments and muscles. So this is the reason why I want to go over the bones first to get a sense of what happens with them, and then we'll move to joints and then to muscles. So the hand is the manual part of the upper limb. The wrist is the junction of the forearm and the hand. And there are a number of bones within there that allow for the various ranges that occur at the wrist. When we look at the digits, it's again, think of the anatomical position. You have the thumb laterally as digit 1, then the index finger 2, middle finger 3, ring finger 4, and then the little finger 5. So think of it from that way. When we, again, in the anatomical position, look at the palmar aspects, you have a central concavity in the middle of the hand, and it sits between two eminences. You have what's called the thenar eminence, which is at the base of the thumb, that big thick pad at the base of the thumb. And then you have another pad on the medial aspect of the hand in the anatomical position. It's smaller, therefore it is known as the hypothenar eminence, and it is proximal to the base of the fifth. When we look at the grips the hand can do, we have a number of them, and we can see them here in action. And we've given them all particular names because it represents all the various things that need to come together for these grips. So first we have the power grip, which is used to grasp a cylindrical object, such as around a pipe or the handle of a broom or something like that. So ultimately what happens, the fingers wrap around and the thumb provides counter pressure in the opposite direction. You then have the hook grip, which is a hand posture that's used when we need fine control, such as holding the handle of a briefcase, for example, or a suitcase. Precision handling, which involves a change in the handling of an object, such as a pencil pen, threading a needle, buttoning a shirt, and so forth. Then we have pinching, which is compression between the thumb and the index finger. And then we have the position of rest. And if you just take a moment while you're listening to this and just take your hand and just hang it out there and just let it completely come to rest, you'll notice that there's slight flexion of the digits and the thumb is abducted. It's away from the midline. That is considered the position of rest. So we can see here, everything's kind of broken down here in the diagram. You can see the hypothenar eminence here at the fifth. You can see the thenar eminence here as it relates to the first digit. And of course, here's all your various grips that occur that allow for things, for all the functional things. The interesting thing is, you think about the chicken or the egg or the cart before the horse. It is the fact that we can do all these functional positions that then inventions have occurred that take advantage of these various grips and or positions of the hand for doing functional stuff or work. So the bones of the wrist and hand, the bones of the wrist themselves, these are known as the carpus. There are 8 bones within the carpus. There is a proximal and distal row. And there are 4 bones found in each row. And we always list them from lateral to medial, again in the anatomical position. So here is the proximal row. So think of the thumb as being over here and the little finger, the fifth finger, over here. So proximal row from lateral to medial, scaphoid, lunate, triquetrum, and pisiform. And again, the distal row, again, from lateral thumb to medial little finger, trapezium, trapezoid, capitate, and hamate. So this is the way they set up. So I do them this way so you can remember there is, we're going to learn there's a very intimate attachment between the triquetrum and the pisiform. So again, here's the lateral aspect, the medial aspect. This is distal, so this would be towards the fingers and the metacarpals. This is proximal, this would be toward the distal portions of the radius and the ulna. You can see them all out here in color as they relate to each other. You can also see them here in the diagram as they relate to the digits as well. So the wrist, the capitate lies proximal to the third metatarsal. So here is the capitate here, and you can see here's the thumb 1, index finger 2, middle finger 3. So you can see the key one here is the third metatarsal to the capitate. So the capitate lies proximal to the third. All the carpals have 6 surfaces to articulate with each other, okay, except the pisiform. Remember, there's 8 altogether. So remember, they're cuboidal in nature from the bone shape. They have 6 surfaces. If you remember a cuboid bone, it has 4 surfaces for articulation and 2 surfaces for muscle or ligamentous attachment. The posterior and anterior surface are rough because of these tissue attachments. The posterior surface, remember, think again of anatomical position. The posterior surface of the carpals form a broader surface, and the anterior surface of the carpals is narrower. So I have a picture here somewhere. I apologize. It'll be later on, but understand that when we look at the posterior surface versus the anterior, we can in some way say that the posterior surface is more convex in nature and the anterior surface is more concave in nature. So the posterior more convex and the anterior a little more concave as these bones relate to each other. These bones, of course, represent almost like a jigsaw puzzle fit together, and because of their nature, they're bound by lots of ligaments that form what are called intercarpal joints, holding all of these bones together very congruently. The position of the carpals anteriorly form this, as I said, this concavity. This sulcus is formed by the anterior surface, and it is known as the carpal tunnel. We'll get into that a bit later. But understand that within this carpal tunnel of this sulcus created by the anterior position of the carpals, you have 9 tendons and 1 nerve that run through that tunnel. The tunnel has a roof on it. The roof is formed by something called the flexor retinaculum, and it is attached to the scaphoid and trapezium laterally, which again are bones of the carpus, and the pisiform and hook of the hamate medially, again bones of the carpus. So we can see here our scaphoid and trapezium here, and our pisiform and hamate here. It's all formed in here. So anteriorly looking in here, the sulcus runs here with a retinaculum lying over the top. 9 tendons and a nerve pass through this sulcus. So let's start with the proximal row first. Again, we're going to go from lateral to medial. So we're starting in the proximal row lateral. The first bone is called the scaphoid. It is the largest of the proximal row. Its name represents the thought that it looks a bit boat-shaped. It does articulate proximally with the distal radius. It does have a very prominent scaphoid tubercle. It is the largest of the proximal row of carpals, and it is the attachment for something called the transverse carpal ligament. We will get into these ligaments after this bony lecture. That will be the next set, will be the joints that involve the wrist and the hand. So you have this attachment of the transverse carpal ligament. The scaphoid, along with the trapezium, form the floor of something called the anatomical snuff box. So just for a brief moment here, if you just take your hand, put your hand in the neutral position to some degree so your thumb is pointing to the ceiling, pull your thumb back actively as far as you can, and you'll sort of see two tendons down by the wrist with a bit of a hole in between, or a concavity in between. So follow the thumb proximally towards the radius ulna, feel two tendons with the thumb pulled back and drop down in that space. Again, we'll talk about this when we get to the joints, but that represents the anatomical snuff box. So they actually used to put tobacco snuff in there and sniff it up their nose. And that's the reason why they called it that. This bone has very poor blood supply. So any damage that is done to it can result in something called avascular necrosis, which interpreted means death by lack of blood supply. Okay, so it can be not unusual to have it removed if there's significant damage done to it. So here we can see the trapeze, or the scaphoid here. Here's the thumb and then the little finger. You can see it sits here. It articulates with the radius proximally, and you can see it here as well. It's relatively large. Here's the tubercle here. We can see here in this aspect. Here's where it articulates with the radius here. Okay, here's your scaphoid here. You can kind of see the shape of it here, and you can see the tubercle lying there. Next is the lunate, named because it's moon-shaped from a crescent moon. It lies between the scaphoid laterally and the triquetral bones medially. It also articulates proximally with the radius. So if you remember when I just did the lecture on the distal radius ulna, we said that the distal radius articulates with the wrist carpus, but because of the disc, the ulna does not. So these two bones articulate with the distal radius as it comes towards the wrist joint. So it articulates proximally with the radius. It is considered to be broader anteriorly than posteriorly, which again helps provide that concavity or that carpal tunnel on the anterior surface. So here's our scaphoid. You can see how it articulates with the radius along with the lunate at this surface here. So we've done lateral scaphoid, lunate is in the middle. Our next bone is the most medial in the row. It's three-cornered, hence its name. It is somewhat pyramidally shaped like a pyramid on the medial side of the carpus. It articulates proximally with the articular disc of the distal radial ulnar joint. So our first two bones, our scaphoid and our lunate, directly articulate with the distal radius, whereas the triquetrum articulates with the articular disc of the distal radial ulnar joint. So it does not articulate with the distal radius or ulna, it articulates with the articular disc. So here we got, again, here's our scaphoid, here is our lunate, and here is our triquetrum here in green. Now you'll note there's a bone that sits on top here, a tiny little bone here, okay? That represents our pisiform. It is a sesamoid bone. It is a small pea-shaped bone that lies on the palmar surface of the triquetrum, right here, and it does provide an attachment, which we'll learn about when we do the ligaments and the joints. And this is highly movable. You can actually grasp it. You'll probably palpate it in lab, or you will be palpating it in lab, and this can actually move. That's our proximal row: scaphoid, lunate, pisiform, and triquetrum. Okay, that's considered your proximal row. Our distal row, again, from lateral to medial. Our first bone laterally, therefore, being the proximal row, it's closest to the metacarpals of the hand. So it's getting farther away from the forearm, closer to the bones that make up most of the hand and the digits. So the trapezium is named accordingly because it's considered a four-sided bone or a table on the lateral side of the carpus. It articulates with the first and second metacarpals, the scaphoid, and the trapezoid bones. So we can see here where here is your first metacarpal, here is your second metacarpal. This is your scaphoid here in your trapezium, and you can see the trapezium articulates with the first metacarpal, the second metacarpal, medially with the trapezoid, and distally with the scaphoid. Remember, this is all the lateral aspect here. Here's the thumb, here's the little finger. Our next is called the trapezoid, was the trapezium. The way I remember it, because it just fits as a little bit of words that sound the same, trapezium thumb. That's how I always remembered it. Trapezium thumb. Our next is our trapezoid. It's wedge-shaped. It resembles somewhat the trapezium. It articulates with the second metacarpal, the trapezium, the capitate, and the scaphoid. So we can see here the second metacarpal, the capitate, the trapezium, and the scaphoid. You can see it's quite a small little bone here. We can see all our articular parts here. Remembering again, 4 surfaces for articulation, 2 for attachment. Our next is capitate. Caput means head. It is a head-shaped bone with a rounded extremity, and it is the largest bone in the carpus. And remember, this is right at the proximal portion of the third metacarpal. So if you take your third metacarpal on the posterior aspect of your hand and slide all the way down that metacarpal, where that metacarpal ends, that represents your capitate bone. So it articulates primarily with the third metacarpal distally and with the trapezoid, scaphoid, lunate, and head. So you can see, if we take the third metacarpal all the way down, it'll take you right to the capitate. It articulates laterally with the trapezoid and the capitate. We can see it articulates medially with the hamate and articulates distally with the lunate. Our next bone is called hamate because on the anterior surface of this bone, there's actually a tiny little hook. So hence the reason for its name. So again, it's a wedge-shaped bone on the medial side of the hand, so right near the little finger now. It articulates with the 4th and 5th metacarpals, the capitate, and the triquetral bones. So here we can see articulating with the 4th and the 5th metatarsals, and articulates with the pisiform here distally and the capitate laterally. Okay? It has a very distinctive hooked process called the hook of the hamate that extends anteriorly. You can kind of see the hook right here, and you can kind of see how it comes out like this. Okay? Oh, sorry, the hamate's here. I'm on the wrong side. I apologize. Okay, thumbs over here, little fingers here. Here's your pisiform, triquetrum. So here's your hamate here, and here's the hook right here. This will turn out, which we'll learn later, is an attachment point for the flexor retinaculum that sits over top of the carpal tunnel, which runs right through here. So the proximal surfaces of the distal row of carpal bones articulate with the proximal row of the carpal bones on their distal surface, and the distal surface of the distal row of the carpal bones articulate with the metacarpals. So we can see it here, that the distal row here, its proximal surfaces articulate with the distal row of the carpals, and the distal surfaces of the distal row of carpals articulates with the metacarpals. So the metacarpals, there are 5, 1 for each finger. They are considered to be miniature long bones, and the metacarpals run from the carpals proximally to the phalanges, which are your digits, your fingers. So from the end, the proximal row of the carpals to the phalanges. And again, if you look at the dorsal surface of your hand, you can make out those metacarpal bones quite easily because it's just skin generally that overlies the dorsal surface. Whereas if you attempt to look at the metacarpals on the palmar surface, there's a lot of flesh there, you can't see them. The first is the shortest of all of them, and they are numbered from the lateral side, the same as the fingers, 1 through 5. The heads of the metacarpals are the distal ends. I'll repeat. The heads are the distal ends, and it is the distal ends that articulate with the proximal bones of the phalanges or the fingers. The heads of the metacarpals, when you make a fist, form what you know as the knuckles. So when you make a fist, what in fact you're looking at are the heads of the metacarpals, and of course in a fist you'll be able to count 4, and that will represent your 4 metacarpal heads from fingers 2, 3, 4, and 5. You can see a knuckle if you roll your hand over a bit. When you bring your thumb into the fist, you'll see the head of the first there as well. Proximal end is called the base. So you've got the proximal end, the part that faces the part that faces the carpals is known as the base, and the distal parts of the metacarpals are called the heads, and of course the heads forming the knuckles. The third metacarpal has a styloid process on the lateral side of its base. So we can see here's the third, there's a bit of a styloid process here on the lateral surface right here. Here we can see our distal row of carpals here, and then we can see our bases are here of the metacarpals with the heads here that articulate with the phalanges of the fingers, and again they form the knuckles. So you'll see here again, base, body, and head of your metacarpals. The dorsal surface of each head has a small tubercle for the attachment of collateral surface ligaments. So remember that they're being held in place. The body of the metacarpals, or the shaft of the diaphysis, is concave on both sides. So they're concave on both sides. And the fact that they're concave on both sides, they fill in, they create a space. And when we get to the muscles, we're going to learn that these spaces are entirely filled in by muscles. We'll get to those later. This is a great slide or part of a slide that will help you in studying where everything is in the hand, okay? The base of the third metacarpal on the dorsal side is a common site for something called a ganglionic cyst. It's just a cyst that can arise there. You'll learn a bit more about that in pathology. On occasion, there is a sesamoid bone found at the first and the second metacarpal. And in this drawing, you can see here, the artist has drawn in sesamoid bones here of the first, and occasionally you'll find some here. And by the way, this, you can see here, is the palmar view of the hand. You can see them here as well in this diagram. The phalanges, they too are long bones, but they are considered to be miniature long bones. Each digit has 3 bones, 3 phalangeal bones, or phalangeal bones, except for the first. So you can see 1, 2, 3 of digits 2, 3, 4, and 5, but digit 1, your thumb only has 1, 2. So 2 phalanges for the thumb, 3 for fingers 2, 3, 4, and 5. You can see the thumb's been pulled away here. 1, 2 metacarpals of the thumb, and then, 1 metacarpal with 2 phalanges, and then 3 phalanges for each other finger. Each has a head, which again, similar to the metacarpal, the head is the distal part of the bone. The base is proximal, and a body or a shaft. The proximal parts of the phalanges are the largest, so if there's 3, the proximal is the largest, and the third of fingers 2, 3, 4, or 5 are the smallest. Not unlike a lot of bones, as we get farther away, as the fingers get smaller, the shafts of the phalanges taper as they travel more distal. Hence the reason why the proximal is the largest, and the middle will be slightly smaller, again tapering, all the way down to the distal phalange, which is even tapered more so. The final phalange, the most distal phalange, the very tip or the very distal part of the distal phalange, the bone is flattened and expanded at their distal ends, and that expanded, flattened area of the distal phalange lies right underneath your nail. So if you have a sense anatomically, it lies right underneath your nail. So you can see here in both drawings, the most distal portion of the distal phalange, so again, proximal, middle, and distal, you can see it's expanded and flattened. And this part here lies directly under the nail bed of your nail, okay? And of course, this represents how the configuration of the hand goes, which we'll get to a bit later. So largest tapering to smaller, midpoint size here with the middle flange, the smallest being the distal. Again, everything tapering towards the very tip, which is expanded and flattened and lies just underneath the nail bed. Thanks for this set. One more set to come. We should be good. And look forward to getting that last one done. And then I'll speak to what we're going to do in class this week. Thanks again.